Hello everyone. Today we shall be going through differentiation from the first principles. So in school when we are taught differentiation, we are given set equations. For example, if y is equal to x to the power n, we are told that dy by dx is equal to nx to the power n minus 1. Now, this is a very elegant equation. However, how we actually got here is quite confusing. And therefore, it is important for us to know what differentiation actually is and how we can actually derive this differentiation from the first principles. So, differentiation is basically evaluating the gradient of a function at any given point. So when we are given a straight line, that is basically the gradient is constant for the entire line wherever we look at it from. However, in other functions such as quadratic functions or quartic functions, the gradient changes consistently. So we need to have basically a method to find the gradient at any given point, and that is what differentiation is used for. Now, to basically analyze how we can differentiate any given function from the first principles, let us consider this arbitrary curve of arbitrary function fx. So we take any two given points a and b, and basically we are going to evaluate the gradient at point a. So point a, the coordinate is x, fx, and point B, the coordinate is x plus h, fx plus h. So basically h here is a small value, a very small value. Let's just keep it at that for now. So if we want to find the gradient at A, let us instead first consider the gradient of this red line over here connecting the 2 points. So for basically any given straight line, we know that the gradient, if we denote it as m, is equal to y2 minus y1 over x2 minus x1. So if we substitute these two coordinates of a and b to this particular equation, where we are basically considering the slope of that particular line, the red line, we get the equation fx plus h minus fx divided by x plus h minus x, that is equal to fx plus h minus fx divided by h. So here, like I said before, h is a very small value. Now imagine a case where h goes to 0. So if h goes to 0, this gap slowly decreases and basically converges to this particular line. And that means b gets closer and closer and closer, closer and closer until it is infinitely close to this point A. And that means this gradient m, when the value of h goes to 0, is basically the gradient at point A of this particular function fx. So when h goes to 0, we can write that as m equals limit h goes to 0 of fx plus h minus fx divided by h. So this, let's take that in red, this particular function, this particular term over here is actually what we call differentiation from the first principles, and it's a very important derivation. Alright, so now that we know the first principles of differentiation, now we can get into an example. Let us consider fx equals x to the power n. So, from what we previously derived, we know that the first principle of differentiation is f dash x. The derivative of fx is equal to limit h goes to 0 fx plus h minus fx divided by h. So by substituting to this principle, we get f dash x equals limit h goes to 0 x plus h to the power n minus x to the power n divided by h. So to compute this limit, we first need to simplify this particular term. So here, the term f plus, x plus h to the power n can be expanded using the binomial theorem as x to the power n plus nc1 xn minus 1 h plus nc2 xn minus 2 h squared, and that goes on until we get h squared. H to the power n. And next, if we subtract x to the power n from this, we get nc1 xn minus 1 h plus nc2 xn minus 2 h squared until h to the power n. And next, to basically get this particular term over here, we need to divide this by h. So that is going to be equal to x plus h n minus x to the power n divided by h is equal to, so ncn is equal to n, so n xn minus 1 plus nc2 x n to the power minus 2 h plus, that goes on until h to the power n minus 1, since that also gets divided by h. So if we apply the limit to this now, that means making all h equals 0. So the limit, applying the limit, h goes to 0, that is, and the opposite of here, n divided by h. We have to make all of these these h terms go to 0. So when all of that goes to 0, these terms gets cancelled out and becomes 0, leaving us with just nx n minus 1. So what we see here is we know very well that if y is equal to x to the power n, the derivative of that is nx n minus 1 to the power n minus 1. So this well-known result is exactly what we got through the first principles. So that's that for this video. I hope you understood the first principles of differentiation. Thank you.